This fall, I attended a public lecture given by Dr. Shane Larson of Northwestern University called Distant Horizons, New Worlds and Age of Discovery. The lecture was given in the Clough Undergraduate Learning Commons, room 144, on Tuesday, November 18th, 2014 at 6 p.m. So, Dr. Larson starts off the lecture by explaining the role of technology in exploration. So, he states at the beginning, saying, in the age of exploration, technology drives discovery. So, that means as technology became more advanced, humans were capable of discovering more and more advanced things that couldn't have been discovered before. This all started with ships that navigated the oceans, and these ships were very technologically advanced for their time, and this led to map making, more accurate maps, and being able to map the entire world at some points by drawing these very accurate maps using very sophisticated types of mathematics in those times. But as time went along, in modern times, telescopes that observe the night sky led to rockets and satellites being launched that travel through space, mapping out the entirety of our universe. So it kind of went from this very global perspective, what can we like it started out as being able to map the whole world. And then once we had mapped the whole world to a very high degree of accuracy, we then said, why not go to the universe? Why not go to the heavens? So after we had successfully mapped the whole world, we would then go to space and start mapping out space. And when technology was advanced enough, we launched satellites to examine stars. We launched the Apollo missions to go land on the moon, and now we are exploring Mars, and we are launching satellites to go to lengths in space that we've never been able to go to before, take pictures of very faraway stars, and be able to map our universe successfully. And so far, we have mapped our universe to, I believe, about 13.7 billion light years away from Earth, which is which requires very technology, but also it's a very amazing feat. So we start off with our planetary exploration by going with Ceres, and for a long time, humans have been exploring planets for centuries, but Ceres is very special. So it was a planet discovered by Italian um, astronomer Giuseppe Piazzi in 1801, and it was later stripped of its planetary status because there were more objects in its vicinity that had the same characteristics. So as they began to discover more and more of these objects that look exactly like Ceres, they discovered something called the asteroid belt, was later named. So Ceres is an asteroid. So it was at once a planet, but the more and more it kept discovering, the more and more we had to say to ourselves, okay, this wasn't really a planet. So it was stripped and later just deemed part of the asteroid belt. But now, in March of 2015, the Dawn spacecraft will visit this object for the first time, not being a planet. So this was once a planet, but it's no longer a planet. But that would be very interesting to visit anyway, given that it has it has a very sentimental status, or it has, a very special status because it was once a planet, but it would still be very interesting to visit. So, as technology advanced, the more and more we could discover. But what also helped our discovery of different planets in our solar system was the fact that we could use very special types of mathematics. So improved technology supplemented with the use of calculus led to the discovery of even more planets in our solar system. So the improved technology would allow us to spot the planets, and calculus would be able to let us track their movements around the sun, so we could predict where planets would be next, so we could observe them more and for longer periods of time, but also predicting knowing where they were. So in 1781, Uranus was discovered by a man named Herschel. In 1846, Neptune was discovered by two Frenchmen named Leverrier and Gall. And in 1930, Pluto was discovered by an astronomer named Tombaugh. But Pluto, again, had the same fate as Ceres. So we start with the word taxonomy. And the definition of taxonomy is the practice of organization of grouping, but not everyone agrees with taxonomy in the first place. Taxonomy is used in a lot of fields, especially for biology, to deem differences between different types of species. So on August 24, 2006, Pluto was demoted from being a planet to being a dwarf planet. And according to leading physicist Neil deGrasse Tyson, who's a curator of the Rose Planetarium at the Museum of Natural History in New York City, he said Pluto is composed mostly of ice. And if placed near the sun, the heat from the sun would melt and evaporate that ice, and Pluto would grow a tail, taking the form of a comet, which is not exactly the behavior of a proper planet. So in reality, Pluto could even be more like a comet, if anything. But more discoveries in that region of our solar system where Pluto is um, found more objects resembling Pluto, leading to classifying it as part of the Kuiper Belt. And so it had a very similar existence and fate as Ceres. Ceres was discovered to be a planet at first, but then more and more discoveries with the rise of technology found all these other objects that looked exactly like Ceres, and they were clustered together, and that formed the asteroid belt. And the same thing happened with Pluto. We thought Pluto was very unique at first, but then the more we discovered, the more we explored in that region, we found that Pluto wasn't exactly so special, and it wasn't really a planet. So we found all these other types of objects, and we called this the Kuiper Belt. So after this vote, the International Astronomical Union decided to officially define the word planet. And this is really weird because for something so special within our own solar system and something that's so significant, we hadn't really had a definition for the word planet, which was very vague and ambiguous over many, many years. So they decided to go with a definition of a planet. So the first point is it must orbit around the sun. So anything that's a planet must orbit around the sun. So Pluto does fit this bill. And the second point is gravity must make the object round. So a planet has to be round. Pluto is round. But the third and most interesting definition is the object must have cleared its orbit. Pluto does not have a clear orbit. But Jupiter, if it was placed where Pluto is located now, would not be able to clear its orbit. So it fails the IAU definition, but it still retains its planet status. So this causes a lot of controversy. So it seems like we deem planets based on almost sentimental and significant value, if anything. So it seems very, very arbitrary. It seems very, very historical. But we still keep Jupiter as a planet, partially because it's so large and there's a lot of sentimental status there. But there's so many technicalities with the definition that we decided to keep Jupiter and strip Pluto anyway, partially because of size. So the IAE definition does ignore exoplanets, though, and there's so many exoplanets in our universe we can't even count. But so far we have discovered 1,849 exoplanets that are known to orbit other stars, and 5,973 exoplanet candidates. And these candidates include what are called rosters, which are planets that orbit so close to their parent stars they're incredibly hot, and they're much bigger than planets even in our own solar system. So we kind of wonder how solar systems like this can even exist. And the second one is rogue planets, objects that have escaped the gravitational force of their parent stars and now just hurled through space, but are still large enough to be planets. So, or were once orbiting a star. So these are two very, very interesting cases of planets or exoplanets. So the main thing, this overarching idea is trying to find planets like Earth. Why does Pluto matter? Why does the definition of planet even matter in this case? So recently we found a very Earth-like planet called Kepler 186f, which has very, very similar chemical properties to Earth. It orbits about the same distance from its parent star. It is larger than Earth, but it still has very, very similar chemical properties, same water makeup. It's very, very similar. So potentially, if we explore enough, we could discover life on this planet. And that's why we explore and why and why Pluto matters. It's trying to understand what makes Earth unique, or even if Earth is unique at all. We are exploring the universe for a variety of reasons, but one of the main reasons is to know if Earth is the only habitable world, and if we are alone, if we are the only intelligent life forms in the universe. And that's why the definition of planet matters. That's why people care so much about Pluto and what is deemed a planet, and that's why we explore. to try to find different life forms in our universe and to see if we are the only intelligent forms of life out there. So that is why we explore, and that is very, very significant to our understanding of humanity and the universe itself.